Hello fellow humans, this is Timothy and you are watching Terra Futura. In this video we'll talk about feasibility and price tag for harnessing solar power and creating sustainable electrical grid. As for example, we'll pick an European country that has a little bit of everything, from hydroelectric, nuclear, coal, solar to wind power generation. And just to be exact, that's 2 wind turbines and half a nuclear. There are clues throughout the video to what country I'm referring to, so comment below if you want to take a guess. This hourly chart represents average electricity production by power source in 2018. In grey we have nuclear, in orange coal, in blue hydroelectric, and on the top in yellow is solar power generation. And as you can see by the red curved line, which portrays actual electricity demand, is that their power grid is self-sufficient. It is also connected to the greater European power grid in order to import or export electricity, which depends on the market price, production and consumption. So if we want for their power grid to be without emissions, we'll need to shut down all coal power plants. Now let's do this in Mythbuster fashion. As we are now 4000 gigawatt hours a year short, we need to find other solutions, such as purchasing electricity abroad, which would result in higher costs for consumers and dependence on foreign countries, expanding on existing nuclear power production that has bad public perception, or adding wind power generation. However, this video is about solar power, and we are focusing on replacing fossil fuel electricity production with photovoltaics in a country with an average solar irradiance. So to meet coal power output, which is for now 14 times greater, we would need to expand on existing 280 megawatts of installed solar to 3600. This increase would require a surface area of around 20 square kilometers, that's 1/3 the size of San Marino or a small Irish potato field. After adding 3400 megawatts of solar, we fixed the problem in theory, but in reality we have midday peaks and nightly deficits. And because of this intermittent nature of solar power here on Earth, we'll need to store the generated surplus to prevent shortages and to balance the grid. There are several large-scale energy storage systems available, from hydrogen fuel cells, compressed air storage, gravity-based storage, flywheels, and etc. But as they're still in development stage and not widely adopted, we'll use proven ones such as pumped hydroelectric storage and utility-scale lithium-ion batteries. As you can see by the green landscape, there is usually no shortage of water resources, and with alpine terrain, pumped hydro energy storage makes most sense. Current pumped hydro capacity in this country is 2.5 gigawatt hours, and it's estimated we would need at least 10 gigawatt hours for reliable daily use. So we would need to add another 7.5 gigawatt hours of storage to cover morning and evening high consumption. The only problem with pumped hydro is the response time, which is up to 15 minutes for it to synchronize with the grid. So to avoid power outages, we would also need around 500 megawatts of battery capacity with a quick response time of around 100 milliseconds to cover peak consumption. First off, let's get some context. The cost of utility-scale photovoltaic system in 2011 was 3,300 euros per kilowatt. In 2016 that number was 1,200 euros per kilowatt, and in 2019 the cost fell to around 810 euros per kilowatt. This cost depends on a specific country, and if you want to see a full cost breakdown, see the link listed below. Now let's calculate how much would this cross-country solar system cost. We need 3,400 megawatts, which equals to 3,400,000 kilowatts times 810 euros per kilowatt, and we get around 2,750,000,000 euros. I know that seems like a big investment, but we get at least 25 years of guaranteed electricity production with small efficiency loss, no fuel cost, and apart from occasional washing of solar panels, there is no other major maintenance in their lifetime. Photovoltaics are also second cheapest power source per constructed kilowatt, right behind wind. Pump hydro system cost varies on a lot of factors, and it deserves a separate video which I'll do in an energy storage segment, so this will be more back of the envelope calculation. Construction cost will be based on existing pump hydro storage in the country, which was built for 53 euros per kilowatt hour. And as I mentioned before, they would need to add at least another 7.5 gigawatt hours. So that is 7,500,000 kilowatt hours times 53 euros per kilowatt hour, and we get around 400 million euros, which is not bad for a system with longer lifespan than that of a human. And as for covering peak demand, there is currently only one large-scale utility battery system located in Horsdale, South Australia, built by Tesla for a cost of 434 euros per kilowatt hour. As we would need around 500 megawatt hours, so that is 500,000 kilowatt hours times 434 euros per kilowatt hour, we get around 220 million euros. And as I mentioned before, there will be more details in a future video. Now that we have all of the ingredients for stable zero emission power grid, let's sum up the cost. We need 3.4 gigawatts of photovoltaic systems, 7.5 gigawatt hours of pump hydro energy storage, and 0.5 gigawatt hours of lithium-ion batteries, which equates to 3,386 million euros. And if we take into account the cost trend of renewables and batteries for the last 10 years, we know that it will drop year by year indefinitely. We see that solar technology and the associated costs are not the real problems. We can apply it to almost any part of the earth and it would be a viable primary power source. Interesting enough is that in places where it would make the biggest impact would also be the cheapest to construct and most efficient. But we're up against multi-trillion-dollar fossil fuel industry and their interests, so there is bound to be pushback at disruptive technologies such as solar, wind and battery storage. This video was about utility-scale photovoltaics, and in the near future I will do a video on why especially solar power with battery storage will be so disruptive. So until then, have a great time.